Flip it back, reverse the track. We're finding inverse functions, mapping outputs back. To find a function's inverse, here's the key. Swap x and y and see what it will be. Every function has an inverse relation you'll find. For the inverse to be a function, the original's 1-to-1 by design. 1-to-1 means hy you see comes from just one x uniquely. If two x's land on the same y, an inverse function can apply. Horizontal lines on the graph display. If the inverse can be a function today, on a function draw a line from left to right. Horizontal test, check it tight. If every horizontal line hits once, you'll see an inverse function can exist indeed. If a horizontal line hits more than once, it fails. It's not a 1-to-1. The inverse function derails. To find the inverse algebraically, follow these steps carefully. Rewrite f of x as y, then swap x and y. That's how you try. Solve for y, that's the next part. Finding the inverse from the start. Rename an f inverse of x when you're through. Domain and range, exchange places too. Graph the inverse, here's the clue. The graph reflects and here's what to do. Across the line, y equals x. Mirror image, no need to guess. Every point flips side to side. That diagonal is your guide. If every horizontal line hits once, you'll see an inverse function can exist indeed. Swap x and y, that's where you start, then solve for y. That's the next part. Flip it back, reverse the track. Inverse functions bring the mapping back.